Welcome back to the deep dive.
Yeah.
We're continuing our exploration of the OEIS,
Right.
the online encyclopedia of integer sequences.
Absolutely.
Where we kind of dig into the fascinating, math stories hidden within these sequences of numbers.
For sure.
And today's star sequence is A000006.
Nice.
And this one kind of takes us on a journey through squares and a little bit of geometric thinking.
Yeah, it's really interesting how this one kind of, comes back to that. We're looking at, integers and how they, relate to each other in these patterns.
Right.
And as always, the OEIS is like a giant dictionary.
Yeah.
But instead of words, we have these sequences.
Yeah.
Each one has its own unique ID.
Right.
Like A000006.
Right.
And a description of the pattern it follows.
Yeah. And today's sequence is defined as number of integers less than or equal to 2 raised to the power of n of the form 4x squared plus 4 by psi plus 5y squared.
Right. And it might look a little intimidating at first. But we're going to break it down, and you'll see it's actually pretty intuitive.
Okay, yeah. I'm already seeing x and y.
Yeah.
So those are our variables.
Exactly. They represent integers, which means they can be any positive or negative whole number, including 0.
Okay.
So we're going to be plugging in different integers for x and y into that formula, and it's going to churn out a number for us.
Okay, so we're going to play with those a little bit.
Yeah, but there's a catch.
Oh.
We're only interested in numbers less than or equal to 2 raised to the power of n.
Oh.
So that's where our boundary comes in.
I see. So for each n, we're essentially working within a doubling sequence, like 1, 2, 4, 8, 16, and so on.
Exactly.
And we're figuring out how many numbers generated by our formula fall within that particular stage's limit.
Precisely.
Okay.
Now, if you look at the comments section, a contributor named Bert Dobbeler, he offered a neat trick.
Okay.
He suggests rewriting the expression as 2x plus y squared plus 4y squared.
Okay.
And this helps simplify things a bit.
So is this always the best way to calculate, or are there instances where the original form might be easier?
Well, it kind of depends. Sometimes it depends on your preference.
Okay.
The specific values of x and y, but generally Bert's method, it gets rid of that SICY term.
Okay.
And it just makes calculations a little smoother.
Okay.
And it's based on a command called completing the square.
Right. Completing the square. I vaguely remember that from algebra class.
Yeah.
Something about parabolas and finding their vertex.
You got it.
Yeah.
Yeah, you're absolutely right. Completing the square does have a visual interpretation related to squares, and it even ties back to the Pythagorean theorem.
Wow.
And it kind of highlights the connection between number theory and geometry.
Yeah, you wouldn't think that a formula about squares would relate to counting integers, but there it is.
Right.
It's remarkable how these seemingly disparate mathematical concepts, they intertwine.
Absolutely.
So are you ready to put our knowledge to the test?
I think so.
Let's take n equals 4. All right, so our upper limit is 2 to the power of 4.
Right.
Which is 16.
Uh-huh.
We need to find all the integers less than or equal to 16 that can be generated by our formula.
Okay.
Using Bert's simplified form.
All right, let's start by plugging in x is 1 and y is 0 into 2x plus y squared plus 4y squared.
Okay.
And if we simplify that, we get 4.
Right.
Which is within our boundary.
Okay, we got our first number. What happens when we keep x as 1 but change y to 1?
Okay, so that gives us 2 times 1 plus 1 squared plus 4 times 1 squared, which equals 13.
Okay.
Still within our limit.
Nice. Let's try another one. What about x is 0 and y is 1?
Okay, plugging those values into the formula, we get 5.
Okay.
And so far, all our results are within our boundary of 16.
And we can't forget about the case where x is 2 and y is 0.
Right, because that gives us 16.
Yes.
Okay, so we found 4 numbers.
Okay.
4, 5, 13, and 16.
And guess what?
What?
The OEIS entry confirms that a 4 is indeed 4.
Nice.
It's like we cracked a code.
We did.
We took this complex formula, broke it down, applied some tricks, and found the specific numbers that fit the pattern.
It's really cool to see it all come together.
Yeah.
And to make it even more clear, the OEIS entry states a 4 equals 4 since 2 to the power of 4 is 16, and 4, 5, 13, and 16 fit the criteria.
This is fascinating. We've only scratched the surface of A000006.
Oh, right.
And it already highlights the beauty of exploring the OEIS.
Yeah, it's amazing how much depth there is to these sequences, even the ones that seem simple at first glance.
Yeah, and it just makes you want to keep digging deeper.
Absolutely.
And see what other secrets we can uncover.
Definitely. Yeah, it really makes you appreciate just how interconnected, different areas of mathematics can be. Like we
Yeah.
started with a sequence and now we're talking about algebra and geometry and number theory all kind of woven together.
It's like a mathematical tapestry,
Right?
with each thread representing a different concept
Exactly.
and ultimately creating something intricate and beautiful.
Absolutely.
You mentioned a contributor named Bert Dobbeler. Is anything known about him?
That's a good question.
Yeah.
I haven't personally looked into his contributions beyond this sequence, but I think it'd be fascinating to delve deeper into, the people behind these mathematical discoveries. The OEIS wouldn't exist without the passion and contributions of individuals like him.
Right. It speaks to the collaborative nature of the OEIS.
It does.
It's like this global community of math enthusiasts
Yeah,
working together to kind of unlock the secrets of these sequences.
absolutely.
Speaking of secrets, I'm curious about the practical implications of A000006. Does it have any real-world applications beyond pure mathematics?
Well, A000007 says itself might not have, direct applications in
Yeah.
fields like engineering or physics.
Right.
The concepts it explores are fundamental to many areas of STEM.
Okay.
Like, for example, quadratic forms, like
Yeah.
the one we've been working with.
Yeah.
They pop up in optimization problems, signal processing, and even cryptography.
Mhm.
Yeah. So even though this specific sequence might not be building bridges,
Yeah.
the mathematical ideas it embodies are essential building blocks for many practical applications.
So it's like the foundation.
Exactly.
That's pretty cool.
It's a reminder that abstract mathematical concepts
Yeah.
often have far-reaching consequences in the real world.
Right.
Like, think about the idea of counting numbers that fit a certain pattern within specific boundaries.
Okay.
Like, that's used all the time.
Yeah.
Especially in algorithms and computer science.
Right.
They often involve sifting through data sets and processing elements that meet specific criteria.
Yeah.
That concept of counting and filtering within boundaries is crucial.
Right.
Yeah.
It's amazing how something that seems purely theoretical can have such practical relevance.
Absolutely. It really shows the power of mathematics as a tool for understanding and navigating the world around us.
For sure.
Now, going back to A000006, one thing that particularly fascinates me is its connection to geometric representations.
Right.
We briefly mentioned, the visual aspect of completing the square.
Right.
I wonder if there are other ways to visualize or represent the sequence.
Mm-hmm.
Perhaps using geometric shapes or by identifying patterns within the numbers themselves.
That's a fascinating question.
Right.
It's like a challenge to kind of explore the sequence further.
Yeah,
And see if we can unearth any hidden visual connections.
exactly. Who knows, maybe someone listening will discover a whole new way to understand A000006
Yeah.
and contribute their findings back to the OEIS,
Right.
adding another layer to this ever-evolving mathematical tapestry.
Right. And that's what's so exciting about the OEIS is it's a living, breathing resource,
It is.
constantly being enriched by the contributions of this global community.
Absolutely.
And it really democratizes access to mathematics.
It does.
Anyone with the internet connection can explore this fascinating world of numbers.
Exactly. It's like a treasure hunt. You never know what gems you'll uncover as you navigate through the sequences.
I remember feeling a bit intimidated by the OEIS the first time I stumbled upon it.
Oh, yeah.
All those numbers and formulas.
Right, yeah.
But once I started clicking around and reading the entries, I was hooked.
It's that initial curiosity that
Mhm.
often leads to the most rewarding discoveries.
Right.
Yeah.
Well, this has been an incredible journey into the world of A000006.
has.
From a seemingly daunting formula to a fascinating exploration of squares and boundaries and collaborative discovery,
Right.
this sequence has showcased the beauty and the depth of mathematics.
Absolutely. And it's just a taste of what the OEIS has to offer.
Right.
With hundreds of thousands of sequences waiting to be explored, the possibilities for mathematical exploration are endless.
And the best part is it's constantly growing and evolving.
It is.
New sequences are being added all the time. Researchers are constantly finding new connections and applications.
Yeah.
So to our listeners who might be new to the OEIS,
Yeah.
don't be intimidated by the initial complexity.
No.
Dive in and explore. You might be surprised by what you discover.
Absolutely. Start with a sequence that sparks your interest. Read the definition, look at the examples, and see where it takes you.
Right.
You might even find yourself contributing to this incredible resource someday.
That would be awesome.
It would.
It's a testament to the fact that mathematics is not a static, completed subject.
Right.
It's a living, breathing field with new discoveries being made all the time.
Absolutely.
We've come to the end of our deep dives into A000006.
We have.
But our exploration of the OEIS is far from over.
It is.
We'll be back soon with another fascinating sequence and another opportunity to marvel at the beauty and power of mathematics.
Definitely. Until then, keep exploring, keep questioning, and keep the spirit of mathematical discovery alive.
Thanks for joining us on the deep dive.
Yeah, it really is. Like anyone can contribute.
Yeah.
And it's a reminder that there's always more to learn.
Well,
even a sequence that seems simple on the surface, like A000006, it can lead to unexpected connections and deeper insights.
It's like we just started scratching the surface here.
Yeah, and it's a bit like, exploring a vast uncharted forest.
Eh?
Each sequence is a path.
Right.
That can lead us to new discoveries and, breathtaking vistas.
I love that analogy.
Yeah.
It really captures the sense of wonder and exploration that the OEIS inspires.
Definitely.
So to our listeners, whether you're a seasoned mathematician or just starting to explore the world of numbers, I encourage you to check out the OEIS. You might be surprised by what you find.
Absolutely. And don't hesitate to dive into those comments sections.
Yes.
You'll find a wealth of insights, alternative perspectives, and even historical anecdotes from contributors all over the world.
Yeah, it's a good community.
It is.
It really is. It's a true testament to the power of collaboration.
It is.
And the beauty of shared knowledge.
Absolutely.
Well, we've reached the end of our deep dive into A000006.
Yeah.
But our exploration of the OEIS continues.
For sure.
We'll be back soon with another fascinating sequence. And another opportunity to uncover the hidden patterns that shape our mathematical universe.
Until then, keep exploring, keep asking questions, and keep that spirit of mathematical discovery alive.
Thanks for joining us on the Deep Dive.